topic is normalization from the database system domain. Let's discuss that what is normalization. It is a process of decomposition of one large relation showing bad schema that has certain problems into two or more smaller relations having no bad design attributes and that do not have these problems is called as normalization. In a simple way, what is normalization? Let's consider one example. If we consider one table which has some bad schema in terms of certain anomalies like insertion, updation or deletion, we have to convert that table, bad schema table into the good schema table to reduce the anomalies or to eliminate the anomalies for maintaining the consistency of the database is nothing but the normalization. It is a systematic approach of decomposition of table to eliminate the data redundancy, insertion, updation and deletion anomalies. EF Cod defined various normal forms of relation as in first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form and domain key normal form. This diagram shows the relationship between between different normal forms. There is a hierarchy between the normal forms. First normal form, then second, then third, then Boyce Codd normal form, then fourth normal form, then fifth, and there are some higher normal forms. But the six normal forms, that is from first to fifth normal forms, are the basic normal forms which we have to know about the different normal forms as in concern with the normalization. Let's consider the example. Consider this table or relation which is named as activity. In this table there are three columns: SID, activity and fee. Here SID is the key attribute. Now in this table we have to apply the normalization to reduce or to eliminate the certain types of anomalies like insertion, updation and deletion. Now for some relations, changing the data can have undesirable consequences called modification anomalies. So if we change some particular data into this table, this changing the data will produce some types of consequences, undesirable consequences, which is nothing but the modification anomalies. And we can eliminate these anomalies by redefining the relation into two or more relations. Now let's see what are the anomalies present in this table. So the first anomaly is deletion anomaly. What is deletion anomaly? By deleting the facts about one entity, we delete facts about another entity is nothing but the deletion anomaly. For example, consider that table. If we delete the tuple for student 100, we will lose not only the fact that student 100 is skyred, but also the fact that skying cost 200 rupees. Second anomaly is insertion anomaly. We cannot insert a fact about one entity until we have an additional fact about another entity. If we want to store the fact, for example, scuba diving cost $175, but we cannot enter this data into the activity relation until a student accepts scuba diving. So these two are the anomalies which are present in the original table, and to eliminate those anomalies we have to convert the table or decompose the table into the two or more relation for maintaining the consistency of the database. Now how we are eliminate the anomalies and divide the tables into the two relations. We have that table in our example, that is activity example. We have one table. We are dividing that table into the two tables. First table is student at table and second table is at cost table. In the first table there are two columns, SID and activity. In the second table there are two columns, that is activity and fee. In the first table SID will be the key attribute and in the second table activity will be the key attribute. Now in this tables, in both the tables, we don't face such type of anomalies like insertion and deletion because we can insert the row or update the row or delete the row individually in each table. Now the first normal form. what is the first normal form? Any table of data that meets the definition of relation is said to be in first normal form. Remember that for a table to be a relation, the following must hold. The cells of the table must be of single value. All entries in any column must be of same kind. Each column must have a unique name. No two rows in a table may be identical. So consider this example, the same example, activity example. In activity there are three attributes and SID is the key attribute. Now in this table we have certain anomalies like insertion and deletion anomaly. We cannot update, insert or delete the rows or columns easily. So to eliminate those anomalies, we have divided the table into the two relations, that is student act table and the act cost table. In the first table, SID is the key attribute, and the second table, activity is the key attribute. So by doing this, we are able to eliminate the insertion and deletion anomalies. So the above two relation is in first normal form as it satisfies all the conditions to meet the definition of relation. What are the conditions of the first normal form? The first one is that each cell must be of single value. No two rows of the table are of the same kind, and each column must have the unique name. This all condition meets here. That's why the above two relation is in first normal form. Second normal form. A relation is in second normal form if it is in first normal form and all its non-key attributes are dependent on all of the key attribute. Now consider this same relation, that is activity. Here SID activity combinedly will be treated as the key attribute. Here there is a functional dependency. We have to define functional dependency here because we have to show that the non-key attributes are dependent on the key attribute. So here in this example, if we are saying SID and activity is the key attribute, then directly phi will be the non-key attribute. So we just have to show that non-key attribute, that is phi, is dependent on the key attribute, that is SID or activity. Here the functional dependency defines activity functionally determines phi. That means if once activity defines phi, then you cannot change that activity with the another phi. So here, for example, swimming cost 50 rupees. So in the fourth row also swimming cost 50 rupees. Now, but that table, this table is having certain types of anomalies like insertion and deletion. That's why we have to divide the table into the two relation in the same way, that is student act and act cost table. Here also SID will be the key attribute, and in the second table also activity will be the key attribute. Here we have to define the functional dependency for second normal form. So the functional dependency here in the first table is SID functionally determines activity, and in the second table activity functionally determines phi. So what is the condition of the second normal form is that the non-key attribute, that is activity. If we say that SID is the key attribute, then ultimately activity will be the non-key attribute. So the requirement of second normal form is non-key attribute, that is activity, is dependent on the key attribute, that is SID. So in the first table second normal form satisfied. Now in the second table activity is the key attribute, then ultimately phi will be the non-key attribute. Now the requirement is the non-key attribute, that is phi, is dependent on the key attribute, that is activity. The second table also satisfies the condition of second normal form. That's why the above two relation is in second normal form, as they all are in first normal form and they both have the single attributes key. As we are saying that if one table is having the single attribute key, then there is not a problem of the functional dependency. That's why both the tables is in second normal form. Now third normal form. A relation is in third normal form if it is in second normal form and has no transitive dependency. Now here we should know about the transitive dependency. Transitive dependency means if A belongs to B and B belongs to C, then A belongs to C. This condition should not be there in the third normal form. Consider the same relation activity where three columns are there. Here SID is the key attribute and the functional dependency is same, that is activity functionally determines phi. This is the transitive dependency present in this table, but they should not be here to satisfy the condition of third normal form. And also this table is having various anomalies, that is insertion and updation. That's why we have to divide that table into the two tables in the same way, that is student act and act cost table. In the first table, SID will be the key attribute. In the second table, activity will be the key attribute. Here the functional dependencies, SID functionally determines activity, and in the second table, activity functionally determines fee. The requirement of the third normal form is there should not be any transitive dependency, but to satisfy the condition of transitive dependency, we must have at least 3 attributes in our table. But as our both the tables are having only 2 attributes present in it, that's why there is not a problem of transitive dependency, and we can say that the above two relation is in third normal form as they are in second normal form, where the non-key attribute is dependent on the key attribute. Both the tables satisfies this condition, and for third normal form they don't have any transitive dependency. That's why both the tables is in third normal form. Now Boyce Codd normal form, a relation is in Boyce Codd normal form if it is in third normal form and if every determinant is a candidate key. Here first of all we have to find out the candidate key, and then we have to define what is determinant. So determinant is what? If we have this type of syntax, that means advisor function determines subject, then the left hand side attribute is nothing but the determinant. So we have to show here that this advisor is a candidate key. If we satisfy this condition, we can say that the table is in Boyce Codd normal form. So consider this table. Here there are 3 columns, that is SID, subject and advisor. Here the candidate key are subject and advisor combinedly can be the candidate key, or SID individually can be the candidate key. Here functional dependency shows advisor functionally determines subject. But this table is having anomalies, that's why we have to divide that table into the 2 relation, that is student advisor and the advisor subject. In the first table there are 2 columns, in the second table there are 2 columns, advisor and subject. Now here SID is the key attribute, and in the second table advisor and subject combinedly can be the key attribute. Now we have to define functional dependency for each table. Here functional dependency is SID functionally determines advisor, and here functional dependency is advisor functionally determines subject. So the requirement of the Boyce Codd normal form is our determinant should be the candidate key. So as we have told, I told about the determinant concept, that is the left hand side attribute is nothing but the determinant. So here SID is the determinant and the determinant is the candidate key. So the first table satisfies the condition of Boyce Codd normal form, and in the second table determinant, that is advisor, is a candidate key. In this way second table also satisfies the condition for Boyce Codd normal form. So we can say that the above two relation is in BCNF as they are in third normal form, and the determinant advisor is a candidate key for the second relation. Now fourth normal form, a relation is in fourth normal form if it is in BCNF and if it has no multi-valued dependency. Consider this relation. Now here we should know about what is multi-value dependency. See, if A belongs to B, then if A belongs to C, this condition should not be present in the fourth normal form. So consider this relation. Here the key attributes are SID, subject, activity combinedly will be treated as the key attribute, and the multi-value dependency is SID functionally determines subject and SID functionally determines activity. This condition should not be present to satisfy the condition of fourth normal form, as this table is having the different number of anomalies. So we have to eliminate that anomalies, but this fourth normal form is having an update anomaly, because we have to update so much of thing to make a simple changes in the data. That's why this normal form is generally not applied. So here this is the example of the fourth normal form. Now this is the review of the normal forms. First normal form, no composite attributes or repeating group. Second normal form, first normal form plus no partial dependency. third normal form, second normal form plus no transitive dependency, BCNF, third normal form plus every determinant is a candidate key, fourth normal form BCNF plus no